Today we are looking at lesson 7.5, Going the Distance, which covers distance formula, calculating distance in the coordinate plane. So today's objective is I can correctly calculate the distance between 2 points in the coordinate plane in 2 out of 2 problems. Makes sense? And we are going to look at a Desmos today. The link is in your class, in the class under content. And let's take a look at that Desmos. So here's the Desmos. We'll go through these slides. Meet Mr. Happy. He gets grumpy when he doesn't know the distance he will be traveling. Move to the next screen to help him. So the first part here, we need to guess the distance Mr. Grumpy travels from point A to point B. What do you think? How can we tell the distance? Maybe we can't. We don't have any markings, we don't have any length measurements, any scale. They haven't given us anything to measure by. So maybe we can't tell the distance between A and B here. So you could type that in here and go through the next few slides. We'll go up to slide 10. You could do that on your own. And then when you get to slide 10, pause the video and we will look at that one together. So pause the video right now, go through the next several slides up through slide 10, and then we'll get back together here. So on slide 10, we are trying to figure out the length between B and C. We're trying to figure out what this length is here. Now we'd already figured out this horizontal length. How did we do that? How did you find the length between A and B on this coordinate plane? Well, maybe you just counted the boxes. We go 1, 2, 3, 4, 5, 6, 7, 8. There are 8 boxes between A and B. So the length here is 8 units. Whatever we're counting on this coordinate grid, there are 8 of them. Now, how about when we went vertically between A and C? How did we find that number? Well, again, same thing. When we are going horizontal or vertical, we can just count them. 1, 2, 3, 4, 5, 6. So this side length is 6. This side length is 8. And now we're wondering, what is the length of this one? Now you might think, initially, we could just count these again, right? We can just maybe count like 1, 2, 3, 4. But when we start doing that, what's the problem? What's the problem with counting boxes like that? Diagonal boxes. Well, maybe you notice that each of these lengths in each box isn't the same. Like this is much longer than this one. And this one is kind of in the middle, and this one's kind of in the middle, this one's really short. These aren't all the same length. So we have to find some other way to calculate that length. Are there any tools in our geometry toolbox that maybe we could use to calculate the length of the hypotenuse of a right triangle? Well, let's see, we had good old Pythagorean theorem, which states that the length of one of the legs squared plus the length of the other leg squared equals the length of the hypotenuse squared. So the length of a leg squared plus a leg squared equals the hypotenuse squared. So this would be C here. So now we should be able to just plug these two values in. We only have one unknown, and we know in algebra if we only have one unknown, we can solve for it. So let's plug these values in. We can plug in 8 for a leg, 8 squared, and then 6 for the other leg, 6 squared, and this should equal the hypotenuse, C squared. 8 squared is 64, 6 squared is 36, 64 plus 36 is 100, and then what's our last step? What's our last step to get C by itself? Well, we have a square, so we need to do square root on both sides to get rid of it. 100 square rooted is 10, because 10 squared is 100. So C is length 10 here. So if you're trying to find the distance between 2 points on a coordinate plane, the key is to making this right triangle. So you can envision, if we didn't have these lines drawn, we were just looking for this length right here, we'd have to imagine where we could make a right triangle. So the rest of this Desmos will walk you through a few of these problems. Give those a try. This is the only one we're going to do together today, so go ahead and go through the rest on your own. And that wraps up our objective. I can correctly calculate the distance between 2 points in the coordinate plane in 2 out of 2 problems. So you will use the Pythagorean theorem to find the lengths of the legs of the triangle and use that in the Pythagorean theorem to find the hypotenuse.